Okay, so in this video we are going to see that what are the distributed database systems. Okay, so we are going to cover the first unit of AKTU syllabus of distributed database systems. So a distributed database system is a collection of logically interrelated databases distributed over a computer network. So we have multiple sites and distributed database system. So say S1, S2 and S3, and we have databases like D1, D2, D3 at these different locations, and these are interconnected and through the network. Okay, through the internet these sites are interconnected. So why do we store these databases at different locations? We are gonna see in the coming slides, and we are gonna see what is the need of distributing the databases and why do we use distributed database systems. Okay, so this is a diagram. As we can see, site 4 has no database which is stored on it, but site 1, site 2 and site 3 have databases, and these sites are connected through the network. So if site 1 access to want tables which are stored in its database, then it can do it locally. But if site 2 wants to access the databases which are residing on site 1, then it needs to move through the internet and connect to the site 1, contact the site 1 and get the results in this way. And similarly, in distributed database systems, we can have sites which do not have any databases like this site. So through the internet it accesses databases of other sites for its use. So what are the applications that distributed database systems was introduced? So the main reason was these are the main applications. So we have manufacturing, especially multi-plant manufacturing. So if there is a big MNC whose manufacturing goes on in multiple countries, so they can store the data like this is the site 1, this is the site 2, or this is the site 3, and all of these reside in different countries. So distributing will help us in this way, like this has database 1, this has database 2, and this has database 3. So they maintain databases of their own sites. Okay, so they have their local database stored at their site. The reason is that they are going to access it frequently. Okay, so other site like S1 want to access the data of S3, it can do it, but it will need the internet access. So there will be some latency due to the involvement of internet and the distance between the countries, all of these stuff. So D3 is local to S3, because S3 is going to frequently use the data of its employees. Okay, S3 will have data of its employees, for example, but S1 can also access the data stored in D3 over the internet. Military command and control. So military is distributed in various parts of countries, like cities of in the same country. So every city can have their own local database which can connect to the internet, and other cities can access them as well. So the higher authorities can see the data of all the sites. Airlines are in multiple countries, multiple cities. So similarly, this is the reason of distributed databases. Hotel chains, it is the same thing. Any organization which has decentralized organization structure. Decentralized means there is not a central organization. Okay, there are multiple offices, multiple chains like JW Marriott. They have hotels in multiple countries. So the hotel in a country or in a city will maintain its local database. Okay, will maintain its local database, like what do they have, how many rooms they have available. Okay, but the head of the JW Marriott or the chairman can access all these data from a discrete location, because those are connected through the internet. Okay, but it will have some latency, just like this example. So that's why the distributed database system is used. Now, what are the promises which are given by the distributed database system? Those are higher reliability, improved performance, easier system expansion, and transparency of distributed and replicated data. Let's see these promises one by one. So what does higher reliability offers, and how does it offers higher reliability? So it offers higher reliability by a replication of the components. Replication means creating multiple copies of a single table or single database. So for example, T1 is a table at site 1, so this T1 can also be replicated, which means its copy can be stored in site 2. Okay, T1 can be stored in site 2 as well. So if for example S1 goes down due to any failure, then T1 is available at S2. So the reliability is increased with the help of this. Now no single points of failure, because we have distributed the copies by creating their replicas, so there is not a single point of failure. For example, if T1 is only stored at S1 and if S1 goes down, then we have lost our entire data, but this does not happen because we have replication. Now example is broken communication link or processing element does not bring down the entire system, just like we see in the example. Now improved performance. How is the performance improved? Like proximity of data to its points of use reduces remote access delays, requires some support for fragmentation and replication. So just like I took the example of hotel chains JW Marriott in the previous slide, like this. So these sites have their databases stored locally to them, so they are going to access it frequently, so they will not put load on the internet or on the network which the organization is having, because they have data stored in a close proximity to them. This is what this point means. Okay, so the data is in close proximity to the access sites, so reduces remote access delays, because we have local database, so we will be facing the delays in only that data which is not local to us. So that's why having local copies will help us in distributed database system to reduce the remote access delays. Requires some support for fragmentation and replication. This improved performance is achieved with the help of fragmentation and replication. These are the two important terms in distributed database system, and we will be covering them in detail in the coming slides with the examples. So easier system expansion. How is the system expansion easier? So if we have a centralized database, so we have issue in scaling them, because of if the database is centralized, so we will have the single network, single machine or multiple machines at single site, so they will put the load on network, so they will put the load on the network, on the CPU, on the single CPU, single machine. So this is why the database becomes difficult to scale, so this is why database become difficult to scale. There will be limited storage at a site. But if we distribute the data onto multiple sites, then every site will have their own storage, their own machines, their own CPU and own network, so that load will be distributed amongst them. Emergence of microprocessors and workstation technologies. So the microprocessor and workstation technologies have emerged a lot in the last few years, so that's why these things become easier, the expansion become easier, because these technologies are getting cheap day by day. Network of workstation much cheaper than a single mainframe computer. So workstations are smaller than the mainframe system. So if we buy a single mainframe for a centralized database system, then it will be more expensive for us as compared to combining multiple small PCs, small workstations. Okay, so the cost will be less of combining small workstations, obviously, because those are cheaper. Now let's come to the transparency. Transparency refers to the separation of higher level semantics of the system from the lower level implementation issues. So higher level semantics is what the view which the user of the database sees. So the user see the high level view of the system, and the lower level view, which are the which cause the implementation issues, those are handled by the developer. So transparency means that the user does not need to worry about the lower level implementation issues. They can access the data or database system seamlessly. A transparent system hides the implementation details from the user, just like we covered in the previous point. Now, a fully transparent database management system provides high level support for development of complex application. Okay. So if it is transparent, which means user will be not seeing the implementation details, so the development can become easy. Okay. Why? Because the users do not need to worry about where the data is stored, how it is coming to them. All right. Next is various forms of transparency that can be distinguished for distributed database management system. Let's see them one by one. So the number one is network transparency, which contains the location transparency. So if I am sitting in Mumbai and the data which I want to access is present in Tokyo, so I can seamlessly access this data because I will not see any issues. Why? Because of the location transparency. I do not need to worry where is the data stored and from where I want to access it. I can easily access it without any issues. This is the good side of distributed database management system. Replication transparency is that I am or the user is not aware that which type of replica we are accessing, or we are accessing from which source, which copy of the data. Okay. Fragmentation transparency, we will come to the fragmentation in the next slide. So user don't need to know that, or don't need to worry, or they don't even know that data is fragmented or replicated. Okay. This is what transparency basically means. The user is unaware of those things or do not need to worry about these things. Transaction, where it is taking place, how many transactions are taking place simultaneously, or failure has occurred. All of these things are hidden from the user. They will see the system working each and every time, or most of the time. Performance transparency, they do not need to worry about performance, how it will be increased or decreased. The performance will be handled by the developers as themselves. Now let's see the basic definition of architecture, because in the coming slide we are going to see the distributed database management systems architecture of distributed database management system. So the architecture of any system, not only database systems but any system, will define the components of system are identified. So what are all the components in the system? That thing is figured out. The function of each component is specified. We tell what are the specific functionality of a component. The interrelationship among the components are defined, how those are related to each other and how they interact, what interact the components with each other in any system is the definition of architecture of any system. So DDBMS might be implemented as homogeneous or heterogeneous database management system. Homogeneous and heterogeneous are two types, and let's see what do they say. All sites use same database management system product. So in homogeneous system, homo means same and hetero means different. So if we are talking about homogeneous, then we will be having similar type of things in any system, and if you are talking about heterogeneous, then we will be having different type of things in any system. Okay. All sites use same DBMS product. DBMS product like MySQL or Microsoft SQL. Okay. So what are Oracle Server, Oracle SQL? So all sites will use the same DBMS product. Okay, it is much cheaper and easier to manage because the things are same. We will be having we will be having the design single design which will work on all the sites, and we will be having special person who are trained in this service or this service, and they can easily maintain at each of the site. The approach provides incremental growth and allows increased performance. The growth can be incremental. Why? Because we can add the databases anytime, we can add the sites anytime because of the same design, and this will help us in performance increase. Now coming to the heterogeneous database management system, distributed database management system is that sites may run different DBMS products. Okay, so in homogeneous, each and every site of that system will have same database product, but in heterogeneous they can have different, like S1 is using MySQL, S2 is using MS SQL, S3 is using Oracle SQL. So these can be the differences. Okay, this occurs when sites have implemented their own database first and integration is considered later. So for example, the companies, multiple companies had same have their own individual system, like C1 has their own database, C2 has their own database, C3 had their own database, and later they merged and they wanted to combine their databases. So then we will be having issues in designing, but it can be achieved, but it will be coming in the category of heterogeneous distributed database management systems. Why? Because they will obviously be having different underlying database products. Next thing, let's see what is the architecture looks like. So this is the computer network and these are different sites. Okay, so they are having first different databases like DB1, DB4 and DBN. Site 3 do not have any database. It accesses the data of all the other sites. It has this data, it has this data. So one thing to look at DDBMS architecture is that for efficiency, like site 4 will be having the data which it accesses frequently. Okay, suppose we have a MNC, so it is in multiple countries, we know it. So like India and USA and UAE, these are three countries. A company is having offices in all these countries. So India will store the data of Indian employees, USA will store the data of USA employees who work in USA, and UAE will store the data of the employees working in UAE. Why? Because UAE, in the UAE we will be accessing our employees data mostly, like their salary, their payroll system, their working hours, all of the thing which can be stored in database will be accessed mostly in UAE, which is generally concerned about its employees. But these are connected through internet, so India can access the data of UAE employees as well if they have permission, but they will be having some latency because India is distant from UAE and they will be accessing over the internet. Okay, so they will be having some latency, but it is possible to access the data via the computer network as it is visible and obvious from the diagram. Okay, so this is how DDBMS works and this is the basic architecture. Next thing is, how do we distribute the data? So we have been talking about distributed database management system. So we have to distribute data or databases or tables or anything, or the rows and the columns which will be covered in fragmentation. So we have two approaches. One is replication and another is fragmentation. So let's see them one by one. First, let me tell you the basic definition. Replication is a process of having multiple copies of a single database or table or anything. So we will be having multiple copies. Replica means exact copy of something, so we will be having multiple copies of something. This is how data is distributed at different sites. Now we have fragmentation. A fragment basically means a part, small part of something. Okay, so we can break tables or databases into parts and then we can store them at different sites, and what is the need and reason and use we will be covering in the coming slide. So let's see how replication works. So means we have replication means having copies of a single table or database at different location. So if T1 is accessed by S1 access T1 and T2 more frequently, then it is efficient to store T1 and T2 at S1. Their replica is S1. Okay, but T1 is accessed by S2 as well, but S2 accesses only T1 frequently, so we will store T1 on S2 as well. S3 accesses S means site, so S3 accesses T3 only, so we will store T3 at S3. This is how replication is basically done, but replication can also be done to maintain the higher availability, like we saw in the previous slides, which were in the promises of DDBS. Okay, but replication have some problems with it. Replication, what does it means? Having multiple copies of something. So we have T1 and T2. So like T1 has 10,000 records. Okay, just let, so it is taking 10,000 records are taking space on S1, and T1 is also stored in S2, so it is the 10,000 records are taking space on S2 as well, so the storage is wasted. This is one of the downsides of replication. Next, coming to the fragmentation. In fragmentation, we break a table into fragments, and it has three types: horizontal, vertical, and mixed. These are the two main types of fragmentation. This one is derived, but a blend of these two. Let's see what is horizontal and vertical fragmentation in coming slides. So let's consider a table, employee table. Okay, so we have three columns: E number, E name, and E salary. Okay, so horizontal fragmentation means breaking the table horizontally. Okay, I will break horizontally like this. In horizontal fragmentation, we have records or tuples. We break the tuples in horizontal fragmentation. So I have fragment F1, and at F1 I have stored these two records. In F1 we have these two records. In F2 I have these three records. Okay, now F1 can be stored at that site which requires only these rows very frequently, which access these rows very frequently, and S2, for example, can store these tables which access it very frequently. S2 accesses these three records very frequently, then it is considered, or it is efficient to store F2 at S2. Now there is one condition: we must have a primary key so that these things can be uniquely identified in fragments. And when we perform union of F1 and F2 or any number of fragments which a table have, then it must give us the original table with all the records. Okay, if a record is lost, then that fragmentation is not considered as a good fragmentation. So this is horizontal fragmentation. Now let's see what is vertical fragmentation. In vertical fragmentation, the data is break in the form of columns. So for example, S1 requires employee names only very frequently. It do not need any other information. So at S1 we will store F1, and F1 is broke in such a way that it contains the employee name. E number is the primary key, so we must have primary key to uniquely identify the records. So when table is fragmented vertically, it will have all the records of the table, all the rows of the table, but will not be having all the columns. It will be having the columns which it requires. Okay, at S2 we can store F2, or at S3 we can store F2 if S3 needs salary only. Okay, so similarly we need to have primary key in that fragmented table as well. As S3 only needs salary access of the employees, then we can have the salary stored at that site with by doing the fragmentation. So fragmentation saves our space. How? Because we do not need to store entire table on a single site. The records which are needed at a site, only those are stored at that site. Okay, only those attributes. So these are attributes, okay, or columns. So what is the condition for this? If I join F1 and F2, I have to perform the join operation, then it must give me the original table. Okay, this is the rule. In this, in horizontal, we need to perform union and we should get the original table, and in vertical we need to perform join and I should get the original table. Okay, so this is how the horizontal and vertical fragmentation works. Okay, now mixed fragmentation is a mix of these. Let's take in this example only. For example, this is the table, so this is in vertical, but I have all rows. Okay, so if I want to convert it into the mix, let's remove these records. So if these records are removed, then in the mixed fragmentation, what do I have? I have the only columns and the only rows which I need. So this is a mixed fragmentation. Okay, so this is how the fragmentation and all the stuff is done in distributed database systems.